Hi friends, welcome to Gate Academy. Day before yesterday I have given you the introduction to structural analysis. The first topic in the structural analysis is like determinacy or indeterminacy of the structures. Fine, this is your first chapter. Determinacy, indeterminacy. In that first we will see static indeterminacy. What is meant by static indeterminacy? There is kinematic indeterminacy also. Before that, first indeterminacy, the first thing see static indeterminacy. In static indeterminacy, further I will divide this into two parts. Static indeterminacy of the structure. What is meant by static indeterminacy? Yeah, I will tell you all those things. Static indeterminacy is further divided into two parts. First one would be external indeterminacy, external static indeterminacy, which is generally noted as DSE. Static indeterminacy, I will give it as DS. Static indeterminacy is given as DS, external static indeterminacy is given as DSE, and internal static indeterminacy. Internal static indeterminacy is given as DSI. External static indeterminacy DS, internal static indeterminacy DSE, external static indeterminacy DSE, internal static indeterminacy DSI, which is further divided into these two topics. And what exactly is external static indeterminacy? External static indeterminacy. Generally I divide the structures into three types: beams, trusses, frames. Fine. For all the things, the common definition or explanation would be simple: number of unknown reactions, over and above number of unknown reactions over and above equilibrium equations. Number of unknown reactions over and above equilibrium equations. So what is meant by this, and what are equilibrium equations, and what are the reactions at the supports, and all those things we will see. But whenever they ask what is external static indeterminacy, DSE, it is number of unknown reactions over and above the equilibrium equations. Fine. Number of unknown reactions over and above the equilibrium equations. Now coming to equilibrium equations or reactions at the supports and all those things, if I have to see, I will take a basic structure, basic beam. If I consider this as a beam, hinge support, I will keep this as some roller support. Different types of supports. Since for many people this is your first class, generally the supports will be discussed in your strength of materials, but here I am giving you an idea. Different supports, the reactions at the supports and all those things. Fine. This is called fixed support. This support is called fixed support. Fixed support. Everywhere that you are seeing right now, all the beam frame connections in your in your home only, if you see there is a beam, there will be a column. Both beam and column, at the end that support is considered as fixed support. Fine. Whenever I say support as fixed support, if I say this as fixed support, you can't move this structure downwards, you can't remove it like this, you can't rotate it like this, you can't rotate, you can't move the structure, you can't move this like this. So that is the reason 3 reactions will be developed. At the fixed support 3 reactions will be developed, like since you can't move like this, so opposite reaction will develop. Since you can't move like this, you can't move like this, opposite reaction will develop. Since you can't rotate like this, opposite reactions will develop. Fine. So at fixed support, how many reactions? 3 reactions. 1 vertical reaction, horizontal reaction, and rotation. So 3 reactions will be there at a fixed support. Whenever I say support is fixed support, number of reactions would be 3 reactions: vertical, horizontal, rotation, because you can't move like this, you can't move like this, you can't rotate. Fine. Next, hinge support. Next type of support is hinge support. Whenever I say hinge support, the best example for the hinge support is your door. Whenever you go out of the room, you open the door, right? It can rotate like this. Fine. It can rotate, but you can't move it like this, you can't move it like this, you can't move like this, you can't move like this, but you can rotate the door, right? The same thing, that is the hinge support. That means at hinge support, you can't move in vertical direction, you can't move in horizontal direction, but you can rotate. You can rotate. Fine. So rotation is available over there. That means here 2 reactions will develop. First one is vertical reaction, something like this. Second one is horizontal reaction, something like this. There will be a vertical reaction, there will be a horizontal reaction over here. 2 reactions will develop at the hinge support. Generally, I am not saying here you will see moment also, I am not discussing that, but generally at hinge support there will be 2 reactions. Fine. Now here also hinge support, if at all I will consider there will be 2 reactions. And now if I come to roller support, roller means it can move in the horizontal direction, or it can move in this direction, it can't move in vertical direction, and it can rotate. It can rotate. You are getting it? So here also there will be only one reaction. Here there will be only one reaction. At roller support means it can move like this, it can move like this, but beam can't move like this, and beam can easily rotate. So roller support there will be only one reaction. So generally if I have to take the number of reactions at fixed support would be 3. Number of reactions at fixed support is 3, at hinge support it is 2, at another hinge support it is 2, at roller support it is 1. Fine. So total number of reactions if you see, 3 plus 2 5 plus 2 7 plus 1 8. Number of reactions is generally given as, here it is given as 3 plus 2 plus 2 plus 1. Reactions I will denote by R, that is equals to 8. Okay. So throughout my structural analysis, throughout my strength of materials, I will be discussing the structures which are in equilibrium only. I am not going to discuss the structures which are not in equilibrium. So this structure is equilibrium, even though after application of the loads, something like this, let us say there are loads something like this, this is W, this is P. The structure I am saying is in the equilibrium. Fine. So because of application of the forces, structure is in equilibrium, structure is not moving, there is no rigid body movement, structure is in equilibrium. Fine. If structure is equilibrium, then what I can say is, if structure is in equilibrium, then number of equilibrium equations if I have to write, then what I can write is summation of forces in x direction is equals to 0, summation of forces in y direction is equals to 0, and summation of moments about any support you can take. Generally I will take this support A. If I take this as support A, summation of moments about support A equals to 0. You can take summation of moments about this support also equals to 0. Any support you can take, but only one support. Fine. So these are the three things. This is number of equilibrium equations, which is generally denoted as S. Number of reactions is 3 reactions at the fixed support, 2 reactions at the hinge support, 2 reactions at the hinge support, 1 reaction at the roller support. And number of equilibrium equations, 3 number of equilibrium equations will be there. Sigma fx is equals to 0, sigma fy equals to 0, summation of moments about any support is equals to 0. Now, if what I said, external indeterminacy is equals to number of unknown reactions over and above the equilibrium equations. Number of unknown reactions over and above the equilibrium equations. Number of reactions here is 8. Equilibrium equations is, yes, if I have to write, I will take it as 3. Fine. So number of reactions is 8, number of equilibrium equations is 3, so DSE is given as 5. This is unknown reactions. That means by using 3 equations, you can find out 3 variables. Any 3 variables. Let us say by using all the 3 equations, I can find out 3 vertical reaction, horizontal reaction, moment. But I can't find out the reactions over here. Fine. So here there will be 5 unknown reactions. Indeterminacy means which you can't determine. Fine. So here the 5 reactions are the one which you can't determine, and these 3 reactions can be easily determined. These 3 or any 3 can be determined, rest of the 5 you can't find out. Fine. So that is the meaning of it. If I say external indeterminacy means number of unknown reactions over and above the equilibrium equations. DSE you got here as 5. So indeterminacy means 5 unknown reactions are there. I can't find out 5 reactions over here. Fine. So that is indeterminacy. If at all a simple supported beam, SSB, simply supported beam, if given, this is called simply supported beam. Fine. If one end is of hinge support, other end is of roller support, then the beam is considered as simply supported beam. At hinge support, how many reactions? 2 reactions. At roller support, how many reactions? There will be 1 reaction. Just now I said at hinge support there will be 2 reactions. At roller support there will be 1 reactions. If I have to calculate DSE, R minus S, number of reactions is equals to 2 plus 1, 3. Number of equilibrium equations is also 3. So DSE is equals to 3 minus 3, that is equals to 0. If DSE is equals to 0, then I call structure as externally determinate. That means all the external reactions can be found out by using equilibrium equations. By using 3 equations, you can find out these 3 reactions. So I will say externally determinate. So this structure is externally determinate, whereas this structure is externally indeterminate. This one you got DSE as 5, externally indeterminate. Fine. So this is how you find out external indeterminacy in the beams. So external indeterminacy I have given you number of unknown reactions, external static indeterminacy. I am not using kinematic indeterminacy. So number of unknown reactions over and above the equilibrium equations. Number of unknown reactions, if I see, before that I have given what is fixed support, what is hinge support, what is roller support. There are different supports also. Over a period of time, by solving the problems, I will get to you. Okay. Now these are the different types of supports. At fixed support there will be 3 reactions, at hinge support 2 reactions, at hinge support 2 reactions, at roller support there is 1 reaction. Number of unknown reactions over and above the equilibrium equations. So unknown reactions here it is 8, equilibrium equations is 3. and DSE is something like this you found out. So if DSE is more than 0, then it is externally indeterminate. If DSE is less than equal to 0, then it is called externally determinate. Fine. If DSE is more than 0, then it is called externally indeterminate. If DSE is less than 0, if it is less than 0, then it is considered equal to 0. If I write it as equal to 0, externally determinate. Determinate means you can find out all the reactions. I am not saying forces, it is reactions. Next, DSE, if it is less than 0, I will say it is externally unstable. Externally unstable. See, this is basics. Basics in GATE examination, you will be really you should 2 marks. If they want to twist the question, they will twist the question here only. So basics throughout your structural analysis, this will be used. I will say what is static indeterminacy, what is kinematic indeterminacy. Based on that only we are going to solve the problems. So basics, very basic. You have to be very clear up to this point. So fine. If you have any doubts, ask in the live chat. I will answer it. Yeah, equilibrium equations. Yeah, if there are 2 loads, I hope you can hear my voice. H. Kumar. So yeah, the equilibrium equations are always 3. Generally it will be 3. In some, I will tell you in the cases where you will take it 2, but right now in a global case you will be taking it as 3 equilibrium equations. Yeah, some more examples will be given to you. I will be discussing, this is just a basic example. We will discuss more and more amount of problems, no issues in that. And Abhinash Karmakar, yeah, I am going to take your doubts, since that was Abhinash. Since it was introduction class, I have not taken your doubts. Now definitely I am going to take your doubts. Each and every doubts will be discussed. You can ask your doubts. Yeah, I will tell you in which cases equilibrium equations are 2. I will discuss those cases when, and all those things I will discuss that. This is just up to this point. Do you have any doubts? Please let me know. And Muhammad Salim, is this lecture for GATE 2021? No, I don't think so, because for GATE 2021 by now you should have completed your syllabus. GATE 2021 is just how many days? Today is January 14th, like February 2nd week you are having GATE. No, if you want to see, you can see. I mean, if you want to clear some basics, you can clear some basics, but no, not GATE 2021. It's for GATE 2022 and 2023 people. Any more doubts up to this point? Fine, if you want to take the notes, you can take the notes over here, or if you can, if it is like you can watch the videos later, that is also okay with me. Anything else? Anything else? Nothing, I don't see anything over here. So can I go to another topic? Next topic, or you want to write something? Fine, I will move on to the next one. This is external stability or external static indeterminacy for the structures. Okay, now for beam actually. Next one is truss. External indeterminacy for the trusses. If I'll consider that. What exactly is difference between truss and the frame? Any idea? What exactly is the difference between truss and the frames? The difference between truss and the frames are, truss are axially loaded members. Trusses are axially loaded members, or it will take either tension or compression, but it will not take any bending. That means whenever you apply the load, a member is said to be truss member if it either, if you are taking tension or you can take compression. The member will take only tension or compression. It will not take any other thing. Member will take tension or compression. It will not bend. If it bends, then it is called frame. It will not be called as truss. Because of application of the loads, load can be applied here, load can be applied here, anywhere load can be applied like this. Because of application of the loads, trusses, see, till now I have seen beams. In the trusses I am discussing right now. So in trusses are the members which will take only axial loads. It will not take any bending. If it takes bending moments, then it is called frames. It will not be called as trusses. Please be very clear with it. Whenever, when I start trusses topic, I will definitely give the assumptions over there. But right now, the idea should be very clear. Trusses, if member takes only forces, axial forces, either in tension or compression, then it is called as trusses. If it takes bending, then it is called as frames. That means these members will not bend. It will take tension or it will take compression, but there will not be any bending in these members. It will not bend like this, 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 something like this. Fine? Now, so here if you want to calculate external indeterminacy, here also it is same. Number of unknown reactions over and above equilibrium equations. Hinge support. Hinge support, how many reactions? 2 reactions at the hinge support. Fine. So 2 reactions at the hinge support, 1 reaction at the roller support. 2 reaction at the hinge support, 1 reaction at the roller support. Number of reactions is equals to 3. Number of equilibrium equations. Number of reactions here is 2, number of reactions is equals to 1, total number of reactions is 3, number of equilibrium equations is also 3. Like sigma fx is equals to 0, sigma fy is equals to 0, summation of forces in x direction is equals to 0, summation of forces in y direction is equals to 0, moment about any of the support, this one or this one equals to 0. So S also equals to 3, here DSE is equals to 3 minus 3, that is equals to 0. So if DSE is equals to 0, I will say the structure is, or truss is externally determinate. Truss is externally determinate. So there is no change in formulas or concepts, anything, while beams or trusses concepts are same. Number of unknown reactions over and above the equilibrium equations. Number of unknown reactions over and above the equilibrium equations, same. DSC is equals to R minus S. Simple. For trusses also. Fine. This is for trusses. Any doubts in this? Any doubts? Any more doubts? Fine. Next one is frames. Next one is frames. whenever I told you difference between trusses and frames is simple. Trusses are the members which will take axial forces only, and frames are the one which will take axial forces and bending also. Axial forces and bending also. Excuse me. Frames will take axial forces and bending also. If let us say this is the frame, because of the frame, that means if I apply the load, this will bend, this will move in horizontal, bending in the sense it will take the bending moment, it will take horizontal movement, it will take vertical reaction also. Fine. In trusses members will not take bending moment, members will take axial forces, either tension or compression, whereas frames members will bend. Members will bend, members take axial forces, tension, compression, everything. Fine. Now, whenever I say DSC, for DSC what you have to do, you have to find out external reactions. First see the supports. Here 3 supports are fixed support. Fixed supports, how many reactions? 3 reactions: vertical, horizontal, rotational. Fine. Hinge support. Hinge support, there will be 2 reactions, as I already discussed. Now the new support came into the picture. New support came into the picture. Whenever you see this type of supports, what exactly is this means is, this is called axial thrust release. Axial thrust release. This is what axial thrust release. What exactly this means is, it can move in horizontal direction, it can't move in vertical direction, and it can't rotate. If you take roller support moves in horizontal direction and it will allow the member to rotate, but here the member will not rotate, but member can move in horizontal direction. Member can't move in vertical direction and member can't rotate. So 2 reactions will develop here, that is one vertical reaction and other one is rotational. So this is called axial thrust release. Fine. Axial thrust release. So here how many reactions? 3, 2, and here also 2. DSC, external indeterminacy, is equals to R minus S. Number of reactions is equals to 3 plus 2, 5 plus 2, 7. Number of equilibrium equations, same 3. Sigma fx 0, sigma fy is 0, summation of moments are also 0. So R is equals to 7, S is equals to 3, DSE. DSE is equals to R minus S, 7 minus 3, that is equals to 4. DSE is more than 0, so this is statically externally indeterminate. I am not yet discussing internal indeterminacy. This is externally indeterminate. Am I clear? So DSE is 4, that is greater than 0, so it is externally indeterminate. Once again I am saying frames. Difference between trusses and frames is, truss is an axial member, it will take tension or compression, but frames takes tension, compression, shear force, bending moment, everything. Frames are the members which can bend, but trusses will never bend. Fine. So once if you see the frames, this is the frames, and DSE is same, concept is same, R minus S, number of reactions. This is fixed support, 3 reactions, hinge support, 2 reactions, roller support, 2 reactions. I am discussing only 2D frames here. 3D frames I will discuss later. While discussing the problems, I will discuss 3D frames. Okay. So 2D frames or 2D structures, everything is 2D over here, 2-dimensional only. So R is equals to 7, S is equals to 3, DS is externally indeterminate to 4th degree, statically indeterminate to 4th degree. Fine. So external indeterminacy is 4. Any doubts in this? Abhinash Karmakar. Yeah, all the time we take 3 for truss. No. Even purely for vertical loading, no. For purely vertical loading, I have not discussed the case, but for purely vertical loading, we will be taking S is equals to 2. Generally, that happens in beam. We will not be worried in trusses actually. Yeah, in trusses, for purely vertical loading or anything like that case, we will take 3 only. In beams, for purely vertical loading, if they say, we will be taking 2. Once again I am repeating it, for beams if it is purely vertical loading, then you will take S as 2. I have not gone up to that case, I will be very much clear at that time. So till now any doubts up to here? Abhinash Karmakar. Sorry if my pronunciation is wrong. Any doubts up to the frames? So I have discussed till now this one, like beams, trusses, frames, external indeterminacy. Beams, trusses, frames, external indeterminacy I have discussed. DSE is equals to R minus S. Concept is simple, R minus S, number of reactions is equals to this one, number of equilibrium equations is also 3. Fine? Yeah. Now, I hope you are taking your notes also, because notes are very much important. Tomorrow while revising, it will be very much helpful to you actually. Fine. You can feel like, sir, I know all these things, I understood right now, but human memory is very less. For every 15 days, if you ask me, it's better to revise everything. Like for after 15 days, you forget. What are the concepts I am saying right now? After 15 days, there is a chances of forgetting it, or after 30 days. So it's always better to have proper notes each and every point. Tomorrow, while revising it, it will be very helpful. Mainly at the end of the revision of your course, that is very, very helpful. So notes plays an important role while this, while reading and while all the other type of stuff. Notes plays an important role. Okay, so yeah, be very much cautious on it. Next one is, till now we have seen external indeterminacy. Now I am going to internal indeterminacy. Internal indeterminacy. Internal indeterminacy, DSI. Internal indeterminacy, DSI, if I consider. So internal indeterminacy is like number of unknown forces, number of unknown forces in the members, number of unknown forces in the members over and above equilibrium equations, number of unknown forces in the members over and above the equilibrium equations. Number of unknown forces in the members over and above the equilibrium equations. Why I am repeating these many times is, so if it enters into your brain, automatically you will solve every question. Okay, that is number of unknown reactions. This is number of unknown forces. Please have it, get the difference in this. Number of unknown forces in the members over and above the equilibrium equations. Fine. The same exercise. First, I'll take beams. So in the beams, if I see something like this, if let us say there is a beam something like this, fine, And if I talk about the forces in the member of the beams, there will be axial force, something like this, right? At any section, if you see member, axial force, and there will be shear force, and there will be moments called bending moment. At any point or any point on the beam, three forces will be there, that is axial force or thrust, shear force and bending moment. Beauty of the beams is, if I know vertical reaction, horizontal reaction, let us say moment over here, there is a vertical reaction, there is an horizontal reaction, let us say, and there is a vertical reaction. Fine. This is for all types of loading. I am not giving vertical or horizontal load. Okay. For all types of loading, these are the reactions. You can calculate DSE. DSE is equals to R minus S. Number of reactions is equals to 3 plus 2 5 plus 1 6. Number of equilibrium equations is 3. So DSE is equals to 6 minus 3, that is 3. External indeterminacy is 3. Well and good, we can calculate. When it comes to internal indeterminacy, number of unknown forces in the members. The thing is, if at all, if you take any member, if I take this member separately, if I take this member, I'll name it as AB. This is A, this is B, this is C. Fine. If I take it AB, there will be like three reactions, something like this, and there will be a reaction, something like this. Actually, there will be moment in depth. I'll discuss that later. But anyway, approximately if it is like this. Now, if I know all the three reactions, all the five reactions, I can calculate axial force in this member. This minus this will be the axial force. Like let us say if this is H1, V1, this is M1, this is H2, V2, or sorry, this is some V2 and this is some H2. If I want to calculate axial force, what will be axial force? H1 minus H2 will be axial force. Fine. At any location, if I want shear force is V1, right? Some of the forces to the left of the section, some are right of the section, that is shear force. Fine. Axial force, this is the axial force, this is shear force. Shear force is sum of the forces to the left of the section or to the right of the section. If I see left of the section, it is V1, to the right of the section, it is V2. Okay, fine. And if I want to calculate moments, sum of the moments to the left of the section or to the right of the section. By using, if I know external reactions, I can calculate forces in the members. So it is not like I know forces in the members. If I know forces in the members, there are no unknown forces. Fine. What is indeterminacy? Number of unknown forces. But here all the forces are known. If I know the external reactions, I can calculate forces in the members. Fine. So that is the reason DSI, internal indeterminacy for the beams, is generally 0, only for beams. I am not talking about trusses. For beams, internal indeterminacy. Why? Because if external reactions are known, all the forces in the member can be calculated, or forces in all the members can be calculated. That's why I am saying internal indeterminacy is 0. So I can say that internally determinate. Internally determinate. So if you want to take a note, you can take the note as if all the external reactions are known, internal forces of the members can be calculated, can be found out So internal indeterminacy for beams, internal indeterminacy for beams is 0. Internal indeterminacy for beams is 0, or we can say that beams are internally determinate. Beams are internally determinate. Beams are internally determinate. If all the external reactions are known, internal forces of the member can be found out. So internal indeterminacy of the beams are taken 0. So beams are taken as internally determinate. And finally, if I want to calculate static indeterminacy, ds, I am talking about only beams. Static indeterminacy for beams, ds is equals to external indeterminacy plus internal indeterminacy. So ds is equals to, generally, because this is 0, you can take ds is equals to dsc only for beams, not for the other things. So that would be equals to r minus s. That would be equal to r minus s. Fine. And now, if ds is more than 0, then it is considered as statically indeterminate. I am not talking about stability over here. Stability and other criteria, I will discuss that later. I am just using determinacy and indeterminacy. You can say statically determinate. And if ds is less than 0, I will call this as unstable. We will be discussing that later, instability and instability, but this is the concept. Fine. ds is equals to dse plus dsi. So from this, these are the things. ds is greater than 0, statically indeterminate, statically determinate, unstable. This is the, so not dse, this is ds. Okay, this is the idea. Any doubts in this? No doubts? Are you there? No doubts? Static indeterminacy, internal indeterminacy of the beams. Yeah, it is always 0 for beams. That's what I am saying constantly. Internal indeterminacy, DSI, yeah, internal indeterminacy is always 0. Yeah, in general means, in many of the cases, all the problems, there was very rare case, exceptions is like only one case, might be one case, that problem can also be solved, not an issue over there. But in the examination point of view, DSI is always 0. Internal indeterminacy is 0, because if we know the reactions, we can easily find out internal forces. All the internal forces can be found out. Fine. Moving to the next topic, internal indeterminacy for the trusses. For trusses, internal indeterminacy for trusses. Generally, if I take any truss, the basic idea I will give you in the truss, if I consider the basic idea, for the truss, if you consider, this is 3-member truss is considered a stable truss. Why? Because the external indeterminacy, if I say number of reactions 1, 2, 3. External indeterminacy, if you calculate DSE is equals to R minus S. So number of reactions is 3, number of equilibrium equations is also 3. So DSE is equals to 3 minus 3, that is 0. That is 0. So externally determinate. Internal indeterminacy. At each and every joint in the truss, there will be 2 forces. Why? Because there will not be bending moment, there will be horizontal force and there will be vertical force. There will not be anything else. Horizontal movement or vertical movement, or horizontal force or vertical force. I can say horizontal movement or vertical movement. So in the member, there will be, like, types of the forces, axial forces only, tension or compression. Fine. So that is the reason what they have given is DSI. Internal indeterminacy of the truss is generally given as M minus of 2j minus 3. M minus of 2j minus 3. What exactly it means is number of members at each and every joint. If you see this joint, there will be 2 forces, right? At each and every joint, you can apply horizontal force and vertical force. You can't apply the rotation. So at this joint, for this joint, you can find out 2 forces. If there are more number of members, you can't find force in that member. At this joint, if there are 2 members, you can find out forces in 2 members. At this joint also, if there are 2 members, we can find forces in 2 members. At this joint also, you can find forces in the 2 members. What exactly it means is, at this joint, I can take sigma fx is equals to 0 and sigma fy equals to 0. At each and every joint, there equilibrium equations will be 2. See, if I say x is equals to 3, this is for overall truss. Sigma fx is equals to 0, sigma fy equals to 0, and summation of moments about supports is equals to 0, any of the support. This is for overall truss. For overall truss, ds is equal, equilibrium equations is 3. But at each and every joint, number of equilibrium equations is 2. At each and every joint, equilibrium equations is 2. So that means at this joint, if there are 2 equations, you can find out 2 forces. Fine. 2 forces you can find. If there is extra member, then you can't find force in that member. If there is extra member, then you can't find force in other joints. Fine. So at this joint there are two members, at this joint there are two members, at this joint there are two members. Fine. But generally what if there are three joints, you expect there should be three members. But how many members are there? I mean, if there are three joints, you expect six members. At this joint, two members, two members, two members. But one basic structure, this is the only exemption where three member truss is stable. This is considered as stable. Why? Because at this joint there are two members, at this joint there are two members, at this joint there are two members. So initially number of members is 3. Number of members is 3 and number of joints is also 3. So 3 minus 6 would be minus 3. That is the reason minus 3 is deducted from it. So dsi is equals to 0 is made. What I mean to say is at each and every joint, there will be two equilibrium equations. For overall truss, number of equilibrium equations is 3. At every joint, there will be two equilibrium equations. This is truss. This is not frame. You can't take bending moments. Fine. So at this joint sigma fx 0, sigma fy 0. At this joint sigma fx 0, sigma fy 0. At this joint, if I take sigma fx is equals to 0, sigma fy equals to 0, I can find out two forces. Fine. So there should be 6 members, but there are not 6 members. 3 members is enough. This is basic stable truss is a triangular truss. That is 3 member truss. This is basic stable truss. Basic stable truss. Fine. So dsi is equals to 0. Overall static indeterminacy is equals to dse plus dsi. I'll take it as 0. Fine. For every addition of one more member, like if I say if I am adding a joint, at each and every joint you should add 2 members. For this joint you should add 2 members. Now if you want to calculate static indeterminacy for this member or for this truss, how you will calculate is 1, 2, 3 number of joints. So dse is equals to r minus s, 3 minus 3, that is equals to 0. For overall truss it is 3 equations of equilibrium, 3 reactions and equilibrium equations is 3. dsi is equals to m minus of 2j minus 3. Fine. Number of members 1, 2, 3, 4, 5 members and number of joints is 1, 2, 3, 4, 4 joints, 4 minus 3. So dsi 5 minus 5, this is 0. This is a stable truss. Why? Because at this joint you have added 2 members. Fine. So at each and every joint you can calculate 2 forces. That means force in this member and force in this member can be calculated. But if I add one more member like this, let us say, now it will be internally indeterminate. If I have to calculate internal indeterminacy for this, dsi is equals to m minus of 2j minus 3. Number of members is equals to 1, 2, 3, 4, 5, 6. Number of joints is equals to 4 minus 3. So dsi is equals to 1. So that's what it means. At this joint there are 3 members. If there are 2 members, you can calculate forces in those 2 members. But since there are 3 members, it will be indeterminate, internally indeterminate to the first degree. So whenever I am saying basic stable truss, generally the formula you can say m minus 2j, but the initial stable truss is a triangular truss where there are only 3 members. Instead of 6 members, there are 3 members is present. That's why you are subtracting 3. If you can understand in this way, or you can remember this formula. So this formula came like at every joint there will be 2 equations. By 2 equations you can calculate 2 unknown forces. Fine. So number of members minus 2j they have did. But the initial truss, if you see, instead of 6 members there are only 3 members. So you have to subtract 3 from that. That is the reason they have subtracted 3 from it. So dsi is 0. ds is 0, this became a stable truss. Fine. So finally, and if I told you like initially I have not used this diagonal member, initially it was 0, but after introducing this diagonal member this became 1. So at this joint there are 3 members. If there are 2 members, you can find out forces in 2 members, but since there are 3 members, it is indeterminate to first degree. Fine. So finally, if I try to write ds is equals to dse plus dsi r minus s plus m minus of 2j minus 3. Generally s would be 3, right? Equilibrium equations is equals to 3. In some of the cases you can see r minus 3 plus m minus of m minus 2j plus 3. So I am taking minus inside. So r plus m minus 2j. This is static indeterminacy. It's up to you if you want to remember this formula, or if you want to remember separately also it is fine. R minus s, m minus of 2j minus 3. It's up to you what you want to do. Okay. And finally same thing goes. If ds is equals to 0, then it is statically determinate, and if ds is more than 0, it is statically indeterminate, if ds is less than 0, it is unstable. So internal indeterminacy in the trusses is different from that of the beams. For beams it is 0, for trusses it is m minus of 2j minus 3. You can use this formula and you can find out the things. See, all these things are basics. Exceptional cases I will discuss at the end. Fine. So this is the basics. Fine. M minus of 2j minus 3 ds is something like this. Fine. Statically determinate, statically indeterminate, unstable. Okay. So any doubts in this? Any doubts? I am seeing only one person giving me the answers. What about the other guys? Come on, everyone is new, Akash. I have just started my topic today. It's just the static indeterminacy and kinematic indeterminacy. In before classes I have given only introductions, so no issues. Harinath, all clarified. It's good to hear. So parallelly type 2 Akash Shukla, how can I approach these all? Approaching means I am telling you the approaches, right? All these things are approaches only for your GATE examination or engineering service examination. So this is just the starting, indeterminacy and determinacy and indeterminacy. For beams I have said something, for trusses I have said something, and I am going to go for frames. You can follow, no issues. This is still first class only, no issues. So don't have any, don't get into any doubts that whether you can approach these things or not. I am here to make you do things. Don't worry about it. Next. Fine. I will go for frames. Is it okay? Yeah. See about the internal indeterminacy of frames. Internal indeterminacy of frames. Generally, what I do about internal indeterminacy of the frames is, I will not calculate internal indeterminacy of frames, because there are different formulas and which gives some major troubles while solving the questions. Fine. So what I will do is, I will find out overall indeterminacy, I will find out overall static indeterminacy, overall static. I will tell you the methods where you can find out overall static indeterminacy ds, and I have told you how to calculate external static indeterminacy dse, and internal static indeterminacy dsi would be equals to ds minus dse. My approach would be, in frames, would be something like this. I'll tell you how to find out overall static indeterminacy. From that, remove external indeterminacy, you'll get internal indeterminacy. Why I am doing this is, for internal indeterminacy there are many formulas, and for many cases you can't easily remember that. Okay, so this is what I am doing. First I'll find out overall internal static indeterminacy, that minus dse will give you dsi. Okay, so the first and basic simple case I am taking, not giving you much trouble here, but don't think all the problems will be like this. Fine. If they ask what is static indeterminacy, external indeterminacy, internal indeterminacy of this frame. Frame idea is simple, it is not a truss member. Frames are the members which will take bending moment, shear force and axial forces also. Okay. Now external indeterminacy, how you will calculate? dse is equals to r minus s, number of unknown reactions. Here it is 3. 1, 2, 3. Everything is fixed support. 1, 2, 3. 1, 2, 3. Fine. So number of reactions is equals to 9. Number of equilibrium equations is equals to 3. dse is equals to 9 minus 3, that is equals to 6. Easy, fine. And to find out overall indeterminacy, what you have to do is, you have to provide number of cuts, so that after cutting, each and every part should behave like a stable cantilever. Fine. So if I provide 1, 2, 3, 4 cuts, after cutting, if I see the structure, how it would be is, so these are the number of cuts, 1, 2, 3, 4. After cutting, the structure looks something like this, and each and everything should behave like a cantilever. Cantilever beam means one end is fixed, other end is free. Other end should be free. So if you see one end is fixed, all the other ends are free. If this is free, this is considered as stable structure. Cantilever beam is a stable beam. If you don't know also, I am discussing it over here. So I have discussed simply supported beam. This is a cantilever beam. If I take cantilever beam, number of reactions would be 1, 2, 3. So dse would be equals to r minus s. So 3 minus 3, this is equals to 0. dsi anyway equals to 0. So ds is equals to 0. So cantilever is a determinate structure. It's a stable structure. Fine. So whenever you are cutting the structure, you have to cut the structure in such a way such that each and every part will behave like a stable cantilever. Fine. Since these are fixed supports, here one end is fixed, other ends are free. Fine. So these are stable cantilevers. Fine. At each and every cut, there will be 3 unknown forces. This is frames. Remember, in trusses there were 2 unknown forces. Fine. Whereas here there will be 3 unknown forces, that is shear force, axial force and bending. At each and every cut, shear force, axial force, bending. Shear force, axial force, bending. Shear force, axial force and bending. So unknowns are 3, 3, 3, right? At each and every cut, I mean at this cut, these are the 3 unknowns, 3 unknowns, 3 unknowns, 3 unknowns. So ds would be equal to 3 times cuts. Three times cuts. I mean, there are exceptions. I'll discuss that exceptions also, but generally, if all the ends are fixed, then you can use 3 times cuts. ds would be equal to 3 times number of cuts you made, so that each and everything behaves like a stable cantilever is 1, 2, 3, 4. Unknowns are 3. 3 unknowns, 3 unknowns, 3 unknowns, 3 unknowns, 3 times 4. So ds is equals to 12. dse, how much you got? dse is equals to 6. ds would be equals to, I mean dse equals to 6, and finally dsi equals to 12 minus 6, that is equals to 6. dsi is equals to ds minus dse. This is how you find out external, I mean overall static indeterminacy. Number of cuts to be given, so that each and every part or each and every part after cutting will behave like a stable cantilever. Each and every part will behave like a stable cantilever. Why? Because cantilever is a stable structure. So whenever I say ds is equals to 3c, c is number of cuts given to the frame, so that each and every part will behave like a stable cantilever, Each and every part will behave like a stable cantilever. ds is equals to 3c, number of cuts given to the frame, so that each and every part will behave like a stable cantilever. Fine. This is for basic problem where this is fixed support, this is fixed support, this is also fixed support. Okay. I'll show you the different cases. Fine. I'm rubbing these things. So if you are having any doubts, okay, I'll keep from internal indeterminacy. Now if you see DSE, external indeterminacy, how will you calculate? 1, 2, 3, and this one is 1, 2, and here the roller support 1. Fine. So DSE is equals to 3 plus 2, 5 plus 1, 6, R minus X, R is equals to 6, S is equals to 3. DSE is equals to 6 minus 3, that is equals to 3. Fine, DSE we found out. Well and good. Now, for calculating overall static indeterminacy, you have to provide the cuts. So I'll cut it over here. 1, 2, 3, 4. You have to check before cutting. So if I cut, this will be a separate structure, this will be a separate structure, this will be a separate structure, fine. You will cut like this. After cutting, how it looks? It looks something like this. Here also it looks something like this. Here also it looks something like this. Fine. After cutting, this is how it looks like. Fine. Now, if I see this frame or if this cut thing, one end is fixed, all the other ends are free, fine, well and good. It behaves like a stable cantilever. But what about this? All the other ends are free, but here it is hinge. Hinge means it can rotate like this. In order to make this as a fixed support, you have to add a moment. If you add a moment, then this becomes a fixed support. Why? Because it can't move like this, it can't move like this, but it can rotate. So you have to add a moment so that it becomes like a fixed support. Idea is to cut the structure so that each and every part will behave like a stable cantilever. Fine. So you have to add a moment here. The same way, if I see this can rotate like this, it can move like this, it can't move like this one only. So in order to make this support as a fixed one, what I have to do, I have to add a rotation and I have to add a horizontal reaction. If I add horizontal reaction and I add a rotation, this behaves like a stable cantilever. Fine. Now see, ds is given as 3 times c minus number of unwanted reactions or number of reactions. I'll use number of reactions. Fine, I'll write ds is equals to here. ds is equals to 3c minus number of reactions added to make it stable cantilever. Number of reactions added to make it stable cantilever. Fine. So the number of reactions added to make it stable cantilever, ds would be equals to 3 times c. Number of cuts is 1, 2, 3, 4. At each and every cut there will be 3 unknowns. That is the reason it is 3 times c. 3 unknowns, 3 unknowns, 3 unknowns, 12 unknowns. But you are adding extra reactions to make it cantilever. Indirectly, at hinge supports moment is equals to 0. That is one more reaction to find out the equations or to find out the forces. Here there are 2 equations, like horizontal reaction is 0 and moment is 0. Anyway, we are adding these things to make it stable cantilever. Subtract those things from your number of cuts. 3 times number of cuts minus number of reactions added to make it stable cantilever. So here how many reactions are added? 1, 2, 3. 3 reactions you are adding. After adding this reaction, this behaves like a stable cantilever. This also will behave like a stable cantilever. So ds would be equals to 3 times c, 3 into 4 minus 3. So ds would be equals to 12 minus 3, that is equals to 9, and DSE external indeterminacy, how much you got? That is equals to 3. That is equals to 3. So DSI, that is equals to ds minus DSE, that is 9 minus 3, that is equals to 6. Fine. This is how you will find out external indeterminacies. Internal indeterminacies. Whenever you have to cut so that each and everything will behave like a stable cantilever. For stable cantilever, add a moment, add a reaction. So that if you add a moment, this will become a fixed support. If you add a moment and reaction, this will become a fixed support. Why I am making it fixed support? So that one end is fixed, all the other ends are free. Fine. So this is how it looks like, and this is the formula overall you will be using. Fine. If these are fixed supports directly, in the previous case these are fixed supports, so you don't have to add any reactions directly, this will become 0, but here you will be adding 3, so that DSI, I mean ds is something like this, DSE, DSI. And finally same concept, ds is equals to 0, statically determinate ds is more than 0, statically indeterminate, and then ds is less than 0, then it would be unstable. ds is less than 0, so it would be unstable. Any doubts? So I mean these are the basic things. I will discuss some more problems. We will see the concepts where you know you will be finding out variations, differences, but yeah, up to here any doubts? Abhishek, yeah, I am here to complete full syllabus of structure analysis. No, this is not crash course. Yeah, Sudham, yeah. This is not crash course, this is full course. Any doubts till now? Even if it is basic doubts, get it cleared now. Its idea is very simple. Whenever you are preparing for GATE or you know any competitive exams, this is not like your university exams where you will be doing one day batting. I was saying this constantly. So all the doubts, get it cleared now only. I am not seeing any doubts, no doubts. Is it clear, or is it like you don't understand anything? Generally we don't get doubts only if it is clear or if we don't understand anything. So let me know if you don't understand anything also, I am ready to repeat, but this is the time, because in future nobody is going to repeat. And the best advantage for this live sessions is you are not, you know, in the class you might feel like somebody feel uneasy and all those things. No, nobody, but you don't have to shy here, you don't have to be shy. It's your mobile or your system you are watching, and you can ask your doubts, all the doubts. Don't need to worry. Don't worry that somebody is going to say this, somebody is going to do this. No, it's your money, it's your time, and it's you who is investing things over here. So get it in that way. From my perspective, it's very clear. It's like demand and supply. You demand, I supply. You demand, I supply. Simple. And we are here like a business proposals. Like very professional, very ethical, and very other things. Get to the point. Any more doubts? No, guys. I am seeing only Kumar. Yeah, I will discuss about that exceptions also. Still you have not seen those things. Yeah. Fine. I will start doing some problems, or we will start doing some problems. If you can solve this question, try to find out static indeterminacy for this frame. These are internal hinges and this is a axial thrust release type of thing. This is hinge support, this is roller support. So how exactly this will look like is fine. There is a hinge support, there is a roller support, and there is an axial thrust release over here. One, two, three. This is called internal hinge. This is called internal hinge. They are asking us to find out ds for this static indeterminacy. Internal hinge. What exactly is meant by internal hinge is, if I take these two members, I'll make a hole in it. I'll put a bolt and nut. Fine. If I put a bolt and nut, you can't move like this, and you can't move in, you can't move like this. You can't move like this, but you can rotate like this. So at hinge support, what happens is you can rotate. At hinge supports, members will rotate, but you can't move like this. This is a hint over here. Based on this, tell me what is external indeterminacy, what is internal indeterminacy for this frame. Try to solve. Till that time, I'll try to see some more problems. Try to solve. Only one person gave me the answers. Other guys, no answer. No answer. Fine. I told you exceptional cases, right? So directly I gave into this question. DSE you can easily calculate. First I'll go with, fine, DSE only will calculate. DSE, number of reactions minus number of equilibrium equations. 1, 2, 3. 1, 2. 1. And here this is axial thrust release. I told you there will be vertical reaction and there will be moment. Number of reactions is 3, 2, 5, 6, 8. So number of reactions is 8. Number of equilibrium equations is 3. So DSE is equals to 8 minus 3. DSE is equals to 5. External indeterminacy is 5. Well and good, easy. Now cuts. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cuts I will make. Why? So that this will be separated, this part is separated, this part is separated, this part is separated. Fine. Now, if I try to draw the separate parts, how exactly it will look like is 1, 2, 3, right? And here there is a hinge, internal hinge. One, 2, 3. Fine. And this one. One, 2, 3. Where is the hinge? Hinge is here. And the final one is 1, 2, 3. This is the support. Okay. Now we have made the cuts, and each and everything should be a stable cantilever. Now if you see, one end is fixed, this is free, this is free, but if you come here, what happens is, I told you if there is hinge, it can't move like this, but it can rotate. So what happens is, 3 members are meeting over here. If I cut it, what happens, these two things will rotate separately. This will be fixed, okay, up to here it is fixed, and then this might fall like this, this might fall like this. Why? Because this is hinge. Hinge means it can rotate. So in order to make it stable cantilever, that means in order to make it fixed like this, I have to add 2 moments here. If 3 members are meeting, I have to add 2 moments, so that here, if I leave it like this, this will be straight, this will fall like this will fall like this. So in order to avoid this, I have to add 2 moments. If I see here, what happens? Up to here it will be straight, and this is hinge support. I have to add a moment so that this will become a fixed support. This will be a fixed support. Okay. Now I'll come till this point, it's fine, it is fixed. And here this 2 might fall and this will fall. I told you, like if it is a hinge, internal hinge that is provided, it can rotate. It can rotate. It can't move horizontal, it can't move vertical, but it can rotate. So this will fall, this will fall, this will fall separately. In order to avoid this, I have to add 3 moments here. Like 3 members are meeting, this will be straight and these 2 will fall like this. Avoid this, add 2 moments. If there are 4 members, add 3 moments. And if you see here, there is a roller support, you have to add moment and the horizontal reaction so that this will be fixed. And here there are any hinges? No hinges. Leave it like that. And if I go here, what happens is, here there is axial thrust release. So that means you have to add a horizontal reaction, then it will be a fixed support. Now this is hinge. Up to here it is okay, it will be straight. This will fall like this. In order to avoid this, you have to add a moment. I am telling you, this has to be stable cantilever, means one end is fixed, all the other ends are free, that's okay. But if there are internal hinges, what happens is it will rotate. In order to avoid this, if 3 members are meeting over here, you have to add 2 reactions. You have to add 3 reactions here. 4 members are meeting, 3 reactions. That means these 2 things will fall, add a moment. It will not fall. Add a moment over here. This will not fall. It has to be fixed. It has to be straight. Fine? So, like that. So you have to add 3 moments so that it will be fixed. Here also you have to add 1 moment so that it will be fixed. Finally, ds. ds, number of reactions if 1, 2, 3, 4, 5, 6, 7, 8, 9. So there will be 9 cuts. 3 into 3C minus number of reactions added. Number of reactions added to make it stable cantilever. To make it stable cantilever. Fine. So number of cuts is 9 cuts. A number of reactions you have added 2 plus 1 3 plus 3 6 plus 2 8 plus 1 9 plus 1 10. So minus 10. 27 minus 10, that is equals to ds is equals to 17, and dse you got it as 5. dsi is equals to 17 minus 5, that is 12. So be very much clear if there are hinges in your examination. This is new concept. If there are hinges, there is possibility of rotations, so you have to add moments to make it stable. You have to add moments to make it stable. Add moments to make it stable. This is also a concept. Fine. So from problems, I'll try to explain concepts like this. Before that all, if I would have told something, you might not understand. So this is how you'll calculate ds, dse, dsi. Any doubts? Any doubts? Difference in static and kinematics. I have not yet discussed kinematic indeterminacy. At that time you will know, Rahul. Until the time static means non-movable, that you can take. So nothing is moving over here. We are just finding out for a fixed beams, I mean for a beams, trusses, frames, that is non-moving. Kinematics is like finding out degrees of freedom, movement. Static means it will not move. It will be fixed at one point. Any doubts? Any doubts? Any doubts? You can note down. At the same time, you can ask me the doubts. Let me know if you want me to stop, so that I'll stop. You can take down the notes. Notes are very much important, which might be helpful to you in the future. We will try to solve some of the questions before stopping today's session. Yeah. This is your gate question only. Try to solve degree of static indeterminacy of the plane frame as shown in the figure. Degree of static indeterminacy of the plane frame shown in the figure. This is the question. If it is not clear, I will draw it for you. This is the question, degree of static indeterminacy for the plane frame. This is the question. GATE 2019 question only, that is. Fixed, hinged, hinged. Understand and do that. See where hinge is provided, okay? You don't have to rush. Think and do it. He is asking static indeterminacy means overall indeterminacy. That is the meaning of it. He is not asking external or internal indeterminacy. He is asking overall indeterminacy of the frame. This is the frame. Hinge is given something like this. What is the answer? Hitin Swami, 15. Thank you, Hitin. Thanks for the appreciation. Yeah, Kumar, I'll give some problems, but for today, do these problems. From tomorrow, I'll give you what are the assignments and all those stuff. So Hitin, if you have taken my PD courses, I think you are giving GATE in 2021, and if you are giving GATE in 2021, yeah, all the best for it. Yeah, all the best, Hitin. Harsha 9, let's see, I got two answers, 15, 15, and someone is saying 9. And for who, if at all people who are giving GATE 2021, if they are in the class, I'll be just giving you some brief idea. Be confident, as we can say, at the end of the day, once if you reach to the end of the examination or to end of the play, we get tensed, right? So don't have that tension. Be confident before the examination. Confident in the sense, not overconfident. Do whatever you are doing daily. Like by now you might have given your exams many test series, so be calm. In the exam also, don't feel like it's a big exam. No, it's like a normal exam. You'll be giving, you'll be scoring it properly without any doubts. Like go do. If you are not able to do one question, fine. Next question, next question, next question. You might have not able to do 10 to 15 questions. It's okay. 16th question, do it. Based on 16th question, then once you get the confidence, come back. It's like I told you, playing test match only. You might not score initially a boundary. Okay, fine, not even a single run. Go. Eat 200 balls, 300 balls, 400 balls. No issues. Nobody is worried about strike rate. okay. But once if you start scoring, then automatically the score will increase. But if you get if you get like confused, or if you get panic, then you lose your wicket. So play defense is fine, no issues. If you're not able to solve first question, second question, 10 question, 15th question, 55 questions is also fine. If you once solve the question, one question, with that confidence you can solve every question. Okay, be confident. Just before the examination you have to be very confident, cool, and do whatever. Like if you play cricket, if you're cool, if generally I play cricket or I watch a movie before any examination to keep myself cool. Right, you have to be very cool. You have studied for 1 year, you have given all the efforts for 1 year. So at the end of the day you have to be very much calm, cool, composed, eat properly, sleep properly. This is not like I'll do whole night I'll study, next day I'll give the examination and I'll get first rank. No, you have to be very much active while giving the examination. This is not university exam, this is GATE or engineering service examination. So you have to be very much cautious, you have to be very much cool, composed. Okay, I'm not saying GATE exam means you have to be no, even for civil services also it's like if you play confidently you'll get score, you score better. If you lose your confidence, if you get panic, you can't score anything. Don't panic, be cool, be cool. If you feel like the question is tough for you, the question is tough for every person in the India. That should be your idea. Like every person is going to do that. If I don't do that, my rank will be no. If you're not able to do that, no one in India will be able to do that. That's it. Because whatever the preparation you did, the same preparation, you are the first ranker. Don't feel like you're last ranker or you're something like this. Whatever the preparation you did, the same preparation will be done by the topper also. Everyone is going to do the same preparation, same type of problems, same thing. Your efforts, your hard work, everything is same. Fine. So if you are able, if you have done your hard work properly, then apply it. Be confident. Don't get panic and don't lose your confidence. I'll say these things. Generally, listening to these type of words also, like it's not. I'll not say much, but idea is simple. Be confident. That's it. Because don't go through much of motivational videos also. That is also like backfires. It will waste your time over there. And social media also, like Instagram, Facebook and all those stuff also, 15 to 20 minutes in a day is enough, not like 15 to 20 hours in a day. Don't get addicted to it. 15 to 20 minutes open. If you want to chat with person, give your information and come back and read, study, be confident and cool, and try to solve some questions, open the books, keep on solving the questions. Okay. That would give you some confidence. If at all, if you feel panic, solve some questions and take out your mind from the studies for some time. Go and play whatever you want to play, watch whatever you want to watch. Okay, so that's like stress relief things. Whatever you want to do it. Coming back to the problem, direct static indeterminacy. So number of cuts: 1, 2, 3, 4. ds is equals to ds is equals to 3c minus number of reactions to be added to make it stable cantilever, Fine. So ds is equals to 3 times number of cuts you have given over here is 1, 2, 3, 4. 4 cuts only, right? Oh, sorry. There is one more thing. Yeah. So there is one more thing. 1, 2, 3, 4, 5, 6. 6 cuts. 6 cuts you will be given. Number of cuts is 6. And number of reactions to be added. Hinge support. You have to add one moment to make it fixed. You have to add one moment to make it fixed. It is fixed. Now, if I see this cut structure separately, there are no hinges in this. So this become fixed, this become fixed, well and good. At here there is an internal hinge. right? So since there is an internal hinge over here, how exactly it behaves is, so where is the hinge? In the second one there is a hinge. There is a hinge here. Two members are meeting over here. So what I told you, if two members are meeting, like up to here it is fixed, this will be rotating. So add a moment here. That's it. So the moment that you have to add is only one moment you will add. So here you will be adding one moment. 1, 2, 3. So the number of reactions you are adding is 3. Answer is 3 into 16 minus 3 into 6 minus 3. So ds is equals to 18 minus 3. That is equals to 15. Simple. 2 marks question. Two marks question, 15. Hardly takes 2 minutes. You know, people have given 15, 15, 15. It's okay, it's okay. For which I have drawn, it's okay. Now you can draw it, okay? No issues. Sorry. Harsha, it's okay. 9 for previous one is okay. For this one, it is 15. Yeah. Harinath, it's 15. Fine. Well and good. Anything else? So 15, 15, 15. Answer is 15. If you have given for whatever I have drawn, like only 2 things, that's okay. That is, for that it's 9. Yeah, well and good. You're good over there. And for this it would be 15. For this question it is 15. Fine. For that question it is 15. Yeah, Kumar. No issues with that. Any more doubts? Any more doubts? Any more doubts? Any more doubts? Well and good. Next. For today, we'll solve one more question. Solve for this also. Why can't you solve this question? Solve this question. Static indeterminacy for the given beam. Static indeterminacy for the given beam. Solve it. Or given structure, I can say. Solve it. This is the structure, static indeterminacy for this given beam. This is hinge, this is roller support, and these 3 are fixed supports. Static indeterminacy for the given beam. I have seen constantly one person is that Kumar is the one who is chatting properly, and the other guys, where you went guys, come, you can answer as soon as possible. Different answers I am seeing. The static indeterminacy for the given beam. This is 2013 Engineering Services examination question. I can solve it here for you. It's just 2 cuts. So 2 cuts means how exactly this will be here? Actually 3 cuts. Either you can treat it as a frame or you can treat it as a beam. Generally I prefer of treating it as a frame. 1, 2, 3, 3 cuts if I do, this will be a separate cantilever, this will be a separate cantilever, this will be a separate cantilever, this will be a separate cantilever. That's how I try to treat it. So once if I try to treat in that way, or I'll try to draw it separately. If I try to draw it separately, find number of cuts 1, 2, 3. So 3 cuts if I do, take this part separately. So 3 cuts, ds is equals to 3 times cuts minus number of number of reactions to be added, 3c minus number of reactions to be added, right? So 3 times number of cuts is 3. Number of reactions to be added is 1 reaction here, and here roller support 1, 2. 2 reactions you have to add, 3. 9 minus 3, that is 6. Your answer would be 6. Answer would be 6. Harinath. What is that r minus 3 minus 1? I don't know, but anyway, answer is 6. Manish Kashyap, nice. Answer is 6. Yeah. Fine. With this, I am closing your class today because it's already 2 hours of time. And in tomorrow class, I'll be starting your surveying, the basic concepts of your surveying. And any more doubts, I'll give you for like 5 minutes window. You can ask me the doubts over there. Till that time, it's Karthik signing off. Good night. It's okay, no issues. I have not given easy problems. This is some basic problems, no issues. I'll give you some practice problems and all those things tomorrow. Don't worry, we'll solve some more problems. But I hope you understood concept. Telegram link is not working. Oh, sorry for that. I'll ask my guys to get it worked. Why don't you directly come to YouTube and type it out, like static indeterminacy, or like tomorrow it would be basic concepts in surveying, geomatics engineering. Yeah. Fine guys, bye, good night.